Alright, so I just wanted to do something that I thought was, maybe kind of fun, and we're just going to, derive the formula for the surface area of a cylinder. So here we have a cylinder drawn, and it basically has two measures. One is the radius, the distance from the center to an edge, and the other is the height, how tall the cylinder is. So, from what we know about shapes and geometry, the surface area is the area of the combined area of the entire outside of the shape. So what we have in a cylinder is we have these two tops that have area. We have the bottom down here, and then we have this middle section that goes around in like a circular shape. So our shapes are this circle that we have as the top, and then we have the same circle. Those really aren't circles, but we get the idea. The same circle is the bottom, and then we have the middle section. So, what does the middle really look like? Suppose that we took a soda can and you cut it the long ways. You cut the tops off first, and you were left with this topless, bottomless cylinder, and then you cut it the long ways so that it flattened out into just a strip. So suppose we cut this cylinder along this dotted line and then flattened the whole thing out. We'd be left with a rectangle. Where if we folded up, if we just attached this end of the rectangle that I'm highlighting right now, and we pulled it over here and attached it to this end, it would look like a cylinder again. So, the surface area of our shape. Well, let's start with the easy stuff. What is the surface area for the top and the bottom? Well, these are just circles with radius r, and the surface area of these shapes will just be the area of a circle. So the area of the top is just going to be, the area for this shape right here is just pi r squared, and the area for this is also pi r squared. So the area for the top and bottom is 2 pi r squared. We're just adding this one to that one. Alright, so what is the surface area of the middle? Well, like I've said, this is just a rectangle, and what we have on the rectangle is the height, and I guess we can call this the length L. That's supposed to be an L. So the height is just equal to, we're just going to call it h, but I'd like to define L as something else. So let's think about where else we're seeing the letter L. Not the letter, but the length L. We have it here, and it's also drawn in this shape. If you notice that our rectangle basically is the folded up version of this circle. So if you start where the color is right now, this red is, and then you took the distance of that path, the length of that path is L. And so another way to think about the length of that path is that is the circumference of our circle. That's the circumference of the top, or the circumference of the bottom, which happens to be the same length as, the circumference of any spot on our shape. Down here too. Anywhere along this cylinder we have some circumference. And the circumference equals 2 pi r. That's the circumference of a circle, so that means that length is equal to 2 pi r. Since the area of a rectangle of this one would be h times L, that means our area of this shape equals 2 pi r h. And thus, the surface area of a cylinder can be found if you know the height of the cylinder and the radius of the cylinder. And we just have to add the surface area of the top plus the surface area of the bottom to the surface area of that middle portion. So our formula is 2 pi r h plus 2 pi r squared. And so this is, I guess, a little bit helpful when we're doing the problem 42 on page 31 in the book. We're given this problem in the book, but I just wanted to show that it's not too crazy difficult to just derive this formula, rather than, if you were asked to come up with the surface area of certain shapes like cylinder or some prisms, you might be able to figure it out on your own. Alright, thanks for watching.